On the discussion thread. Here we go, problem number 19. We have f of x is equal to negative x minus 2 squared. And then they give us this parameter, which means x is less than or equal to negative 2. So we can verify on our calculator, but I think these are rigged up in a way so that way you could just go to work. Okay. So now what we're going to do, what was the first step? Who can remind me?
Solve.
Well, we've got to change f of x to y. So I say y equals negative x minus 2 squared. Then what?
X and y.
We're going to flip-flop the x's and y's. We're going to switch them around. So this will be x is equal to negative y minus 2 squared.
Solve for y.
3, we're going to solve for y equals some stuff, right?
Yeah, always.
Okay, so now
Okay, how do we do
to solve for y is not that hard, okay?
Oh, you just take.
There's lots of ways I could do it, but the square, some of you might be tempted to
factor it out?
like expand it and multiply it out. But no, what we want to do is, there's multiple ways to do it, but what I'm going to do is I want to take the square root of this,
Yeah.
but there's a negative here. So I could divide everything by negative 1 first, right? And that gives me negative x is equal to y minus 2 squared. And then I'll take the square root of both sides. Now I'm not real worried about having the square root of a negative x at this point.
Can you put the negative on the outside? That's what I did.
No.
Oh.
No, because you have to take the square root of everything. So when I take the square root of a square, I get y is equal to, or y is equal to, or I'm sorry, it's equal to y minus 2. It's the base is what I'm trying to say. And then over here, I've just got the square root of negative x. And I suppose if we were going to be like algebraically correct, we might want to focus or keep in mind that when you take the square root of something, it's plus or minus, right? So now what I'm going to do is I'm going to add 2 to both sides. So I get 2 plus or minus the square root of negative x is equal to y. Now this plus or minus thing, we can choose the principal root or the negative root. And it really depends on the graph and the parameter that they set for us. Okay? It is not... In other words, I need to decide which one I should focus on. Okay? Because one of these may be what we call an extraneous solution. In other words, what we've done is we've said that y is equal to 2 minus the square root of negative x, or y is equal to 2 plus the square root of negative x. Okay? And so both of those could be our inverse function. So how would I do that? How could I determine if it's both or if it's just one or what the deal, how do I do that?
Well, graph them.
Good. That is exactly what we're going to do. We're going to graph the original function, okay? And so the original function was, let's come in here, and we'll clear this out, and we will say negative times the quantity x minus 2 squared. And then I'm going to come down here and I'm going to clear this out. And we said we're looking at x is greater than 2, right? Or x is less than or equal to 2. So what I'm going to do is I'm going to come in my window here and I'm going to change, I'll make this like negative 5 and then I'll make my x max at 2. Now let's just see what we get. Let's graph it. Okay. So it looks like it goes down, so I'm going to change my window a little bit in the y direction. Let's make my y min be like negative 5. There we go. So this is my graph right here. So what I'm looking for is a graph that's going to kind of reflect up here, correct?
Right.
So now which one of those would do that? Well, let's just plug one in. I guess, I mean, we could speculate, and I'm sure there's a good reason, but let's just try the first one and see what we get. So if I do 2 minus the square root of, whoops, wrong one. The square root of negative x. Let's graph it and see what that does. Hey, that looks pretty good. All right. Now, if I come in here and I change that, let's see, maybe both of them are, but I highly doubt it. So which one is the obvious inverse function? The minus. So what we're going to do is, that's the one we're going to go with, so let's change that. Okay. Graph. There it is. All right. So we've used the graph. And now what we want to do is we want to verify that algebraically. Oh boy. So in order to verify that algebraically, what I would need to do is I'm going to have to take f of f inverse of x. And what should that look like when I'm done with that process? Should equal x, right? So let's start with what f of x is. So f of x is equal to negative x minus 2 squared, and f inverse we said was of x is equal to 2 minus the square root of negative x. So now if I'm going to do f of f inverse of x, here's what I want to do. I'm going to look at my original function of x. So here's my x right here, and that's all this stuff here, right? So wherever there's an x, I plug in an x. Now if I'm going to take f inverse, in other words, I'm going to take f of f inverse, the graph, or the, I'm sorry, not the graph, but the function is written the same, but wherever there was an x, what do I plug in now? F inverse. And I'm just going to pause for a second and let you guys kind of soak that in. Do you see what Mr. Adams did? All right. So now I really am evaluating f of all this stuff here. Does that make sense? So I'm going to say f of 2 minus the square root of negative x, which is equal to negative the 2 minus the square root of negative x minus 2, all that squared. All right, here we go. Let's finalize that. So this is really f of f inverse. Okay. So on the inside, I've got 2 minus the square root of x, negative x, minus 2 squared. Well, what happens with my 2's? They cancel. So I've got negative times the negative of the square root of negative x squared. Is that right?
Yeah. But would the negatives just cancel out, like, besides the one inside? Besides the
I think there would be still one negative. I think maybe Mr. Adams made a mistake somewhere, but yeah, if I'm gonna, did I make a mistake somewhere? Because if this is squared, then it really ends up becoming like, oh, it's negative x, right? So when you square a square root, you get the base. So you get negative x. You guys threw me off for a second there. So f of f inverse of x, and then f of f inverse of x will be x times negative x, which is x.
Wait, x times.
So basically, in proving it, you're just trying to find f of the inverse of f equals x.
Yeah. So yeah. Well, think of it this way too. Like this is how we prove it algebraically. But let's think of the concept of the inverse function. All right. And so let me tack this on real quick. Here, you can just have this. If I have some value for x, okay, and f, some function f transforms it into a y value. It doesn't matter what this is. We'll plug in a number just to see, okay? So let's say that this is 2. I plug it into a function and it spits out 5. What I should be able to do is take that and the inverse just undoes what was being done. Okay? So now if I take x, which is in the domain, and I push it through the function f, that will give me f of x. But now if I push that through the inverse, what will I end up with? X. And that's why we would say that f of inverse, or f inverse of x should always equal x. Because we start here, we do something to it, that gives us the f of x value, then we plug it back into the inverse and we end up right back here at x. Does that make sense?